Alright, one more example here. What I'd like to do is find a unit tangent vector to the curve r of t equals, component functions are e to the t cosine of t, e to the t sine of t, and e to the t at t equals 0. In order to find a unit tangent vector, we'll need a derivative, and then we'll be dividing by the magnitude of that derivative. So, finding a derivative, looks like we're going to need the product rule a couple times here. So for e to the t cosine of t, that'll be first times derivative of the second plus second times the derivative of the first. For the second, we'll do the same. First times derivative of the second plus second times derivative of the first. And then differentiating e to the t gives e to the t. Now what you could do is simplify this expression a bit, but since we have a value of the parameter, I'm going to say let's go ahead and plug that in. So plugging in t equals 0, we are going to get 1 times negative 0 plus 1 times 1. That's because e to the 0 would be 1, sine of 0 is 0, and cosine of 0 is 1. Doing the same thing for the next one, that's 1 times 1 plus 0 times 1. And finally we have 1. To simplify this as much as possible, we get about the most boring vector that we could possibly get, the vector 1, 1, 1. The unit tangent vector is defined as the tangent vector that has been normalized, so that'll be r prime of 0 divided by the magnitude of r prime of 0. So we'll be taking the vector 1, 1, 1 and dividing by its magnitude. So that'll be the square root of 1 squared plus 1 squared plus 1 squared. That, of course, would be the square root of 3. So our unit tangent vector to the given curve at the given value of the parameter is going to be 1 over the square root of 3, 1 over the square root of 3, and 1 over the square root of 3. Good stuff.